on. Dear friends of the KITION Planetarium Observatory, dear members, I would like to welcome you one more time to our online science cafe with subject tonight, what's on the sky. So we are going to share with you what's on the sky this month and what was on the sky recently. As you most probably know, since 2008, the KITION Planetarium Observatory has offered science cafe sessions for all visitors to share their passion for science and astronomy. Since January 2021, visitors from different parts of the world participated in our online sessions, discussing observations, the latest news in astronomy, and sharing their knowledge and achievements. In this online meeting, which is dedicated to observations, we'll talk about the most spectacular phenomena possible to be observed with different methods available for amateur astronomers, starting from naked eye observations to binoculars and large aperture telescopes. We will give you a couple of words related to recent meteor showers, a comet, supernova, variable stars, but also for our asteroid discoveries. And we might give you a little task. Alexander will let you know earlier. And we also have a little chat from our members and volunteers. Our guest speakers are Mahdessian and Matvey, Dubishkin, and Brina. So, Alexander, the stage is yours.
Thank you. So let's look at the sky. But before we do that, let's go to the ground and look. Is it possible to get some knowledge about celestial bodies when we are looking on ground? Yes, indeed, it is possible. This summer will start 21st of June at 12:14 Cyprus time. So very wonderful moment. It's not always the summer starts exactly around midday in Cyprus, but here we are very lucky. And of course, we just put in a rod in soil. You have the first astronomical instrument which humans had from I don't know, for eternity, most probably for all the existence. It is a gnomon. And as we learned already last Science Cafe, Dr. Perez Rodriguez Raul Perez Enriquez told us that it is good moment to start and calculate our own gnomonic factor at this very place where we are, at this very beach where you put your rod in the sand. So it's good moment for you to start your observations of the sky with ground. Okay, that's what really going right now, and a lot of press all over the world, and even we in KITION Planetarium Observatory receive requests from mass media what's going on with meteor shower. They don't even know the name because of it's very specific. It is tau-Herculids, but the story started with the comet Schwarzmann-Wachmann 3. And in 1995, it was observed that the comet started to become not one, but two fragments. Look at accurately. Here it is, large and another large. It passed, the comet already passed the sun on its way back far away to the outer parts of the solar system. It divided into two parts. Later, it was discovered more parts, so we have more fragments, and the main body of comet now is named fragment C, so not even A. Anyway, that moment, a lot of dust produced, and it is this very dust, which is according to calculations, had to meet with the Earth again, not just this years, but this hours. Now we have this moment when it is the Earth passed through this dust. Well, where we should observe? we should look at. We should look at this point not far from Arcturus, and the name is τ-Herculids because of 90 years ago the radiant was in Hercules constellation. It drifted during this time, and now it should be somewhere here. So it's easy to observe when this map is for Cyprus evening, and you see that it is practically at zenith. So very excellent situation because of the estimation zenith per hour rate is always when we expect that the radiant is in zenith, and then you have so many meteors per hour. So it is Cyprus which has this good position. So very simple, very interesting. But that's what makes intriguing this meteor shower is it's the speed of meteoroids. It's just 16 kilometers per second. It is very, very small. Usually 30, something like that, 40, okay, the maximum is 71 or around Leonids. But 16 means, first of all, it is very slow. Second, they are not bright. Okay, let's have a look. On 28th of May, at 1908 Universal Time, there were observation from Cyprus, and we observed not just this meteor from τ-Herculids. It's very simple to recognize it. It's very slow, but we observed an interesting phenomenon, zenith attraction. Schiaparelli in 19th century was the first who predicted and explained that this zenith attraction should happen with meteors, and mostly it is visible on very slow meteors. Okay, this is an approximate drawing of the meteor which was observed at 1908. Standard procedure is we have to pass two lenses back, and that will be the individual radiant of this very meteor. Of course, it does mean that meteor radiant is precisely here because of there is a certain area of from where meteor around radiant, from where meteors come. So they not always come precisely from this point. They come from around it. But we see that definitely we have drift, very large drift for about 12 degrees. How to estimate 12 degrees? This distance from here to here, from alpha to gamma, is 10 degrees. So it's definitely larger. So we have a drift of meteor from the predicted radiant to zenith. That's what was observed with this meteor. And all 4 meteors which were observed from Cyprus, they all show this zenith attraction drift. So it's really, we observed not just τ-Herculids, we observed even an interesting phenomenon which was predicted by Schiaparelli, developed later, and in 2007 the very accurate theory of this phenomenon was constructed. And about same period, a bit later, Jürgen Rendel, he was president of International Meteor Organization for many years, some time ago. He made observations of everything and of τ-Herculids, of course, and it was his first session. Here it is. And as we could see, to be sure that he observed exactly τ-Herculids and not to confuse with anything else, he made meteor coordinates estimated directly procedure. That's why he wrote in his report not counting, but letter R. Later, he used counting because of there were many, no needness to prove that, yes, he observed precisely that very meteor shower. Notice that meteors were not bright in comparison with other, even with sporadic antisolar radiant, which show regular +1 and more. Those were just 2, and still they show that they are not bright. and our observations from Cyprus show same. And here indicated again the same effect that he observed the shift for more than 10 degrees to northern waters due to zenith attraction effect. So this τ-Herculids meteor shower shown interesting phenomena, not just common observations of meteors. Well, this is the outcome of this meteor shower for a few hours ago. So that's what we have. And this is a contribution to this estimation made from Cyprus. So there were just few meteors at this moment and this moment, and that's why estimations based on Cyprus observations were important to find these numbers. And in general, even those who observe just few meteors or 0 meteors per year session, it is required to make your report to supply your data. Kiti, would you like to add something, because I know that you're awake today morning?
Yeah, I mean, if they were magnitude 2, then I wouldn't have seen them because the conditions weren't great this morning.
Mm-hmm.
So I didn't see any, unfortunately.
How long did you observe?
I was 20 minutes.
So it's great. It's a long time. So you may supply your data that yes, you observed.
Yeah.
I observed this night. Before midnight, I saw 1, and after midnight, I made a break, and I saw just 0. Again, same 0. Well, okay. Let's have a look at the results of a winner. So here we are. Karl Hergenrother, he observed from the United States. He divided his observations of 2.5 hours in 10 minutes session, very short, because of it is expected for this very meteor shower for scientific reasons to make short sessions. So he divided in 10 sessions, in 10 minutes session. And here he was granted on dark sky, so the limited magnitude practically 6, so it's really dark sky. He was granted for during 10 minutes to saw 10 meteors, in average 1 meteor per minute. Very, very powerful activity. But look, immediately after nothing, then a bit something, then again nothing. So it shows not steady maximum, but still that's the best result which I found. The results are still coming. People are still continue to supply their data. So preliminary, let's say right now, this is one of the best observation of maximum of this meteor shower. So it follows a general recommendation. It was recommended to observe maximum when night is over Atlantic Ocean and the United States, let's say at the American continents. So here we are, maximum really happened there. And still, it is still recommended to observe today and tomorrow for scientific reasons, again, to get our zeros and supply them. Yes, we see zeros. Maybe we are lucky, we see more. When I say like this, in fact, you see, I remember a story with Perseids meteor shower last year, when 2 days after the main maximum, we already had another one, which was even higher. Okay, Kiti, you want to say something?
Yes, I can't really wake up at 4 a.m. again and do it because, you know,
No, Kiti, right now
maybe,
it is
maybe
evening.
as soon as this is over.
Yes, exactly. Evening is the best now. The closer to maximum, but the closer is evening, and at evening we have overhead the radiant. So the best position right now, the best position to supply our zeros and maybe 1, 2.
And hopefully we have another outburst.
Yeah, maybe because of there were predictions concerning not 1990 5, but about 1892, if I remember correctly, and another one which should happen on 30th and around 1st of June. So we still should continue our observations. Well, so if we said, okay, it's enough about this meteor shower, here you may make print screens. Here is a timetable for others. We still have, we name it daytime ARI meteor shower. It's going now, and many others up to Perseids. So there are a lot of things to do this year. Well, so the meteor showers is the most spectacular for visual observations when no other instruments are required. But if you have some optics, let's say binocular, you may do interesting observations with it. And Ara Mahdessian, could you tell us about your own binocular?
Yes, actually, I would say that mine is a monocular.
Okay.
Okay, that's good. Thank you, Ara.
Thank you.
Nice
Also,
pair of binoculars anyway. Not yours. Oh.
yes, I will talk about my monocular.
Mm-hmm.
Can you change the slide? Yes, this is my monocular. I have it next to me right now. And I got it from my aunt's house in Greece. And it is old, but it works. So I brought it to Cyprus and I often use it. I was told I belong to pirates, but now I asked my uncle to confirm. He said that either it was used by pirates or it was used by naval military, but it was definitely used on ships. So this uses a poroprism. So as it has the same structure as refracting telescopes, the image that we get is rotated by 180 degrees. And these prisms, they rotate it back so that we can see it normally. They do this by two right-angle triangular prisms, and the light is totally internally reflected. And apart from this, it also increases the focal length as the light has a greater distance to travel, and this increases the magnification. Actually, I Googled it, and it appears that when I Google poroprism monoculars, most of the result is binoculars. I don't know why, I just wanted to share it.
The poroprisms are used in the so-called spotting scopes now with the big K7 mirror usually.
Yes, but they are still used in binoculars, and you can see the pictures.
Excellent.
To focus on an object, you need to turn the eyepiece left or right. If you turn it counterclockwise, it increases the distance, and clockwise, it decreases the distance from the objective lens. And I actually found this today when I was making the presentation. And to find the field of view, I needed to find two stars that when I looked through the monocular, they were at opposite sides. They could barely be seen at the same time. And Mizar and Alkaid worked. So to calculate their angular distance, I could use spherical trigonometry, given their coordinates, but that's a bit tricky. So instead I Googled it, and I found it is 6.8 degrees, and that's my FOV. The diameter I measured using a ruler, and it's 52 millimeters. And the angular resolution is the smallest angle between two objects that it can resolve, so that they don't look as one. And we use the formula theta, the angle which is in radians is 1.22 lambda over d. Lambda is the wavelength of light, and as we're looking at visible light, it is 550 nanometers approximately, and d is the diameter, which I found is 52 millimeters, and therefore the angular resolution is 2.66 arc seconds. So you can see many things like the moons of Jupiter. The theoretical limiting magnitude is the maximum magnitude that you can theoretically see using it. And I use the formula that it is 8.8 plus 5 log d, which I got from this website, this article in NASA, which seems to be correct. But unfortunately, the diameter is in inches, which is not SI units. So I converted it and I found it is 10.4 magnitude. But this is much greater than the one that I could see, which is 6.5 from Nicosia. And so there are many reasons that this could be. Firstly, light pollution. So the dimmest stars I can see with my eye are magnitude 3.5, and that's if there isn't any dust, which is much less than 6, which is what you can see in dark areas. So theoretically, we would expect the limiting magnitude to be 7.9, but still that's greater than 6.5. Another reason this could happen is because I found out how the focus works today. So many of the objects that I was seeing may not have been focused before. And also it is old, so it may be damaged or the lenses may be dusty, even though I don't see any dust. For the magnification, we will use the formula that is equal to the apparent field of view over the true field of view. The apparent field of view is the field of view that you would expect to see, you would expect to have if there was no magnification at all. And I found that it is approximately 45 degrees. And we calculated that the true field of view is 6.8 degrees. So that gives a magnification of around 7, which makes sense for monoculars or binoculars. There are many things that you can see with it. In Nicosia, you cannot see as much, but you can see open clusters like the Coma star cluster, which is the one I've drawn in the image. It's not a real picture. The Alpha Persei cluster and the Pleiades. Unfortunately, you cannot see Pleiades now. But in dark skies, like in Greece, where I went in the summer, you can see many Messier objects like the Andromeda Galaxy, which I have drawn there, or the Orion Nebula. And like once this winter, I went to Jordan in the desert where there was no light pollution, and I counted 10 or 20 of them. You can see many things. And this is a real picture that I took from my phone today. At the back, you can see the Pentadactylot Mountains. And thanks for listening.
Thank you very much.
Congratulations, Hara. Interesting presentation. I also like your pictures you used.
Thank you.
And I like that you put your own pictures. What's about this picture? Was it how much time it took for you to draw it?
Not a lot. I just put a picture of the of my binocular using my phone. Then I added a black picture from the internet, and using the draw button, I just put some dots where they appear to be in the stars.
Mm-hmm. Okay.
It didn't take that much time.
Okay, I understand. Some more questions?
Yeah. When you said you visited which place in summer?
Jordan.
Jordan in winter.
You used this specific monocular?
Yes,
Okay.
because it's the only one that we have, or the only good one that we have.
Mhm. Nice.
And of course, those days you did not measure limited magnitude, but was it much better than 6.5? How do you, at least
Yeah.
from your experience, say?
Yes, definitely. You could see 6 with your eyes there.
Of course.
And it would be probably much closer to 10.4, maybe not 10.4, but at least 9 or 9.5.
Okay. Great. Thank you. Some more questions. One more question.
Anyone would like to ask any question? Okay.
Well, we started with naked eye, then we went to monocular, and now we are coming to telescopes. And our student, Matvey Dubishkin, who attended Astronomy Academy as well as Ara, will present his talk about his own telescope.
Hello.
Good evening.
Hello. Yes. So can you see it? Okay. So I'm gonna present my telescope now. So I got my telescope as a gift for a New Year in 2018. It has a zoom of 20 and 60 times. So first of all, I have found a field of view of my telescope. To find it, I use the Zeta-Virgo star. It is very close to the celestial horizon. It has declination only minus 0.35 degrees. So then I did the calculations, and I have found that at the minimal zoom, it has the field of view 1.83 degrees, and the max zoom is 0.96 degrees. So the next one is the limited magnitude. So to find it, I use the star clusters between the Ursa Major, Arcturus, and Spica. So here I have it zoomed, and I use the stars to find the limited magnitude of my telescope. So after a long observation, I have found the limited magnitude at the minimal zoom is 9.05, and at maximum zoom 11.45. So now about the object I have observed with this. So first of all, I have observed the moon's terminator. I didn't find my own drawing, so I put the Google one. So next is the Mars and Moon occultation. During the observation, I have typed the exact time in seconds what was happening with the Mars get behind the moon and other stuff, but I didn't find these two. So also about planet observations, I have observed the Venus phases. So I have some drawings. Also, I have observed the Jupiter and Saturn conjunction. I did not draw it, I just observed it for fun. And yeah, and the other stuff like Jupiter's moons, the Jupiter himself, the Saturn's rings, and other stuff. So the next one is the deep sky objects. So most of them are the Messier objects. I have some examples. I have also I have observed something also besides the Messier, like different stuff. I love things. Yes. Also, I use my telescope to observe the variable stars, especially the ones in the Cassiopeia constellation. So I have here the star map of the variable stars, and I have the magnitudes of them in the different days and hours. So this is the from the previous year. This one is the most recent ones. So yes, the most recent one I observed is the lunar eclipse. So it happened in the 16th of May, and I tried to take some photos using my action camera. Just put it in the ocular and took some pictures. This is some of the best ones I took. So there is the shade of the Earth on the moon. So yeah. In conclusion, I think my telescope is a very powerful telescope for its sizes. It's small. It can see very many stars and objects. It's very good. Yeah, that's it. I hope you liked.
Thank you, Matvey. Questions?
Matvey, congratulations, because with a telescope less than 100 euros, you managed to do a lot of science. And if I remember well, it's the spotting scope, yes?
Yes.
The present one. So we are talking about the same photo configuration with BK7 prisms. And yeah, I think the only thing we did to help, actually, you reconstructed the telescope, you removed it from the tripod and you put it on a base,
Yes,
the
Dobson.
Dobsonian base,
Yes,
correct?
yes, I forgot to mention that.
Yes, this it gave you more stability and
Yes.
portability.
Yes.
Wow, excellent.
And moreover, it allowed to observe very high.
Yes. the Dennis too.
I have a question.
Yes.
Do you put it on a table to do your observations?
On the top of the roof, I have like some wall. I put it there and use it as so. And no, if there's just a wall, I put it on the wall and observe things I need to observe.
When Matvey said on the roof, I was he means that there is a roof like a floor, and in the middle of this floor there is a kind of wall, so not very high, but and you may use it like table.
Yeah. Okay. So it's not going to fall off the building or anything. That's
No,
good.
yes, of course, it's perfect for safeness, and it's very and it's comfortable. I would not say very comfortable, because of you have for some you don't create this wall, so some area of sky is not visible clearly using that wall, but it still is good.
All right, thank you.
Yeah, thank you. Oh,
I have a question about estimation of limited magnitude. Do you make, Ara said about calculations, and yours, yes, here it is, yours data 905 and so on, how you manage with it?
I just pointed the telescope at this star cluster, and I observed for a very long time, and like so this one which is the less bright, it just appeared for an instant and then vanished.
Okay, so these are data from your own observations, correct?
Yes.
It's
Yes.
not calculations. Okay,
Yes, yes.
and what's about the previous slide?
Yes.
You mentioned a star, but you did not explain how from the star you get these numbers.
Well,
Field of view.
so the whole sky is divided by 24 hours. So this is 86,400 arc seconds. So I divided the 316 by 86,400, I found a number, and then I multiplied it by the time the star was passing by my field of view.
Yes, that's what I was asked. So you put a star on the edge of field of view and start counting time.
Yes, yes.
Now I understand. Thank you.
Yeah.
Okay, one more question. Okay, thank you very much, Matvey.
Yeah.
Thank you for your presentation. So now we know what shall we do with telescopes. Even small telescope could be could produce fun and be interesting for science as well.
Yeah.
Well.
And Alexander, Alexander now will talk to us about Meet LX90 and some projects. And after Alexander, our friend from England, Christagis, will have the chance to share with us some of his new images taken with his also robotic telescope.
Okay, so when we have a telescope which allows us to observe anything on the sky, we could see phases of Venus. Here we could see that it's really around half of disk, so it's near greatest eastern elongation, 28th of November. We could observe very tiny details on the moon. It is easy to take photo of it because of the moon is bright. You may take a picture just part of a second, and here you are. Or, for example, again, bright objects. It is Jupiter and Saturn conjunction. That's one which already mentioned by Matvey. So 21st of December, that was the closest. And it was in one field of view, both planets together. These are for bright objects, which I could show you, but there are many not so bright objects which are still possible to observe with this meet. For example, we observe asteroid occultations when an asteroid hide from us for part of second star. So to make these observations, and stars are usually very dim. The limited magnitude of the telescope is better than 12.5. Because of 12.5, I clearly saw during such observations. So that's what, when we have larger telescope, we could observe a lot of other phenomena and objects. And when you have not just telescope, but telescope which could collect light for a long time, robotic telescope, then we may ask Christakis what will be the result.
We have to mention here that all the pictures with the LX90 were captured with LG, with LG G4 mobile Android device over the eyepiece. So this is a different part which we called smartphone astrophotography, and we had sessions last year related to smartphone astrophotography for photographing the moon and sunrise and sunsets and the galaxy and star trails with smartphones, and also took some measurements of brightness of stars. Christagi, could you share with us some of your beautiful images with your beautiful camera?
Okay, can you hear me all right?
Yes.
Yeah, okay.
You may also share.
First of all, I'll show you my new telescope. It's if I can bring it forward and you can have a look, it's a 8-inch. Yeah, can you see that? Yeah.
Yes.
So it's an 8-inch with dedicated camera, all run one-shot color. It's got a focal length of 1600 millimeters. I haven't put a reducer on it yet, but my other one was a refractor, so this has given me a little bit more closer views, and it's very heavy, so I'm going to have to put it down. So I've really only had it for the last few weeks, in fact 2 weeks. The photograph I've got behind me, the image, that's the Crescent Nebula, NGC 6888. That was one of the first ones I took with the camera. But if I can share my screen, if I can go on to, if I can go on to my,
Nice background. Was probably a Greek island.
that's Land's End down in Cornwall.
Oh, cool. Okay.
So if I go into my gallery, these are the objects I've taken, some of them recently, but some going back a little bit. If I go into here, these are the ones I've taken recently. So with my, as I say, with the camera that I've got now, ping is probably the best one to show. So that's the NGC 6888. You'll see that on my new telescope, it's actually got diffraction spikes on the stars, which some people like and some people don't, but I can't get away with it. They're there at the moment. So that's, yeah, I can't get rid of them. The other one I did 2 nights ago. These are all my sort of working files before I put them into. I don't think I could show a fits on there.
So your camera is doing auto stacking, yeah?
No, I don't do auto stacking with the camera. I just I download everything and then process it in AstroPixel processor. But if I can show my where's my ping file? It's a lot smaller. Otherwise, it takes a long time for some of these. This is my stacked image of a galaxy M90, which is in the Virgo, and I don't know what this little one here is as well, but I think it's called the Siamese twins. It's 2 interacting galaxies here, but as I say, the images I'm getting from my new telescope are much closer. I'm taking 3 and 6 minute exposures and then stacking them together. So that's about 2 hours of images stacked together and a little bit of post-processing in Photoshop. So that's that one. I also used, where's 9.24? Oh, the spider, nebula. I can't, to be honest, I can't even remember doing some of these, but this is the Iris Nebula, which is rather a nice object, absolutely beautiful actually. I mean, it looks like an iris flower, which I quite like. Again, I've got the diffraction spikes because of the way the mirror is held on the camera. So that's the Iris Nebula. What have I gone into here? No, it's better. I'm just trying to see what else I've got at the moment, which I can show you. The cocoon, was that recent? No, that was back in August. I'm just trying to find things that are in the sky at the moment. The bubble, that was back in February. I say these are images that I've taken sometimes over more than one night and then just put them all together. but that's the bubble nebula there. I say I'm getting much closer with some of the images I'm getting, which means focusing, tracking has to be that much better. Because if you can imagine, I'm looking in at a very, very close part of the sky, and I'm trying to stay on that one particular point for 6 minutes every time. Well, obviously everything's moving. It's actually quite difficult, but as I say, I've got a little guide camera which locks onto a star and just makes very small movements on the mount to keep everything, you know, perfectly positioned. And as I said, that's about two or 3 hours of individual images. On their own, they're not particularly remarkable, but when you put them all together and then you stretch the actual image, then you can get some idea of what's available. That's the bubble. I'm just trying to think what else I've got that I've done recently. Those are all quite.
There's one in May there, 13th of May.
Sorry?
There's one there, 13th of May, 20. Virgo Galaxy.
Yeah, that was the Virgo one. Yeah, that I did. As some of them were done. Just trying to think, because there should be some with the 294 and the April, May.
What camera are you using now?
It's a one-shot color. It's a 0533, which is a square. It's got an actual square image. I don't use the 294. Have you got a 294?
And now we're going for the 533C.
The 533 is excellent because the problem with the 294 I found with me when I was using it with my refractor is you get amp glow, so you get quite a bright almost star effect in one corner of the camera, just caused by the electronics in the camera, but you don't get that with the 533, so that's why I particularly like that one. I'm just trying to see, those are the, so those, for instance, these are the individual images that I can't open that in on here. But yeah, so the 533 is it's a much more tolerant camera. It doesn't have all this amp glow, so it's actually a lot easier. Oh, that's let's have a look at this one. This was it's called the hairdryer Galaxy, which is quite nice. Again, I think that's in Virgo. I think if you use your imagination, it looks like a hairdryer. I suppose that's why they've called it that. But yeah, so that's the hairdryer. To get my focusing and everything, I did look at the moon, because one of the hardest things I found on this is actually finding where the focal point is. I know it sounds quite straightforward, but it's actually it was quite difficult to find the focal point. The difference with doing the moon is instead of taking 6-minute exposures, obviously, as you said, Alexander, it would be overexposed, you know, because it's so bright, that I was just taking 20 milliseconds of shots, and then I stacked it all together. Yeah, image things in the sky that we wouldn't normally see. So that's how I spend my nights sometimes.
It needs patience.
Yeah.
But you manage to relax, enjoy the night sky, nature, and play with technology. Experiment.
Okay, let's proceed So we know what to do when we have large telescopes, and this is a challenge for those who have it. These days we have bright comet, not so bright, it was 6 practically, but now its magnitude is 7.6. So it's become dimmer, dimmer, dimmer. This is its short name, 45P. And we could see that it is altitude 6 degrees, 8 degrees, so very low near horizon. At evening sky, you may observe it. And it was discovered by Honda, Merkos, and Dusakova. And it moves, as you could see, practically like the sun, so along ecliptics, very, very close to it. And it goes just in front of the sun. So all this time it will be in the same bad conditions, very low near horizon, and become dimmer, dimmer, and dimmer. But if you have challenge and this challenge, if you have passion, you may try to catch it as well. So this is a map. You may make a print scan if you want. Well, so that's for about comets. And a supernova happened to explode recently in Virgo constellation. It is M60. In fact, it is not M60. It is NGC 4647. But those who are keen in deep sky objects, they know that next to Messier 60, there is one galaxy, NGC 4647. Let's have a look at it. So here we are. This is our elliptical M60, and next to it there is, okay, how it look? It look like a spiral galaxy. Okay, let's continue. That's what we have recently. This is our M60 and NGC 4647. Do you see difference between these two pictures? Yeah, here it is. It's supernova. And it's so bright that it's brighter than the whole galaxy. It's definitely brighter than center of galaxy. So that's what we have these days. It was this picture was the discovery picture. So on 16th of April, but now it is dimmer, dimmer, and dimmer, but it's not so dim. Have a look how it looked 26th of May, just a few days before. So we still have it brighter than the galaxy. So for next 2-3 weeks, the situation will be similar to what we have now. So you still may observe it and enjoy M60, which is not difficult to find on the sky. And something extra next to galaxy. Something similar I observed by my eye with large telescope when we saw, we didn't see the galaxy. We saw only center of galaxy like a star, some stars as the background of our Milky Way, and just additional star, supernova from that very galaxy. So similar situation. But by naked, not naked, by visual observations with telescope, with camera and taking picture, it will be much more intriguing. Well, one more interesting thing, it is observation of a nova. We have one specific type of novas. We name them dwarf nova. It is a white dwarf next to a red dwarf, and when the activity happened, it repeats every 71 days for the specific star. The material from red dwarf accreted on the white dwarf, and when the hydrogen was in enough quantity collected, it erupted, it exploded in thermonuclear fusion. So we have we observe thermonuclear fusion not inside a star but on its surface. So this happened every 71 days with the star, and the next maximum should be in July this year, and Hubble Space Telescope will observe it. So during minimum it is 17 magnitude, but during the eruption it is 11. So welcome, observe it with telescope, even with visual observations, and all over the world, all amateurs of astronomers are welcomed to help these observations together with Hubble Space Telescope. Because of not only the Hubble telescope, but other data are important during this season. Well, you know already that KITION Planetarium and Observatory participated in program of asteroid search, and this is the list. We could be proud of this list. This is the list of our discoveries. And we use this disk at our Astronomy Academy. And one of our students made research what's the best to observe out of these asteroids this summer. His name is Brynja. Brynja, are you ready?
Yes.
Welcome.
With Alexander, we saw a few asteroids that can be interesting to observe. And asteroid 2021 CQ27 is interesting to observe because it has elongation of almost 180 degrees. It can be observed this summer. It has 21st absolute value. Here is the scheme I made to show estimate position of an asteroid. This gray thing is asteroid, and this is Earth.
And what about others asteroids? Why you don't like to observe them this summer?
And other asteroids are about in this part of orbit.
Okay, thank you. Thank you very much, Brynja. Let me proceed as well. So our student found out that out of the whole list, only this one is the best for observation. And this observation should be done now in June, for example, because of these days we have the elongation is 166 and so on degrees, so the best time for observation. If you could see here, we see, you notice that rotation period is not known. So if we use very large telescopes, such as 1 meter diameter and larger, which could allow you to observe with apparent magnitude 21 and very accurately, then we may, during 3 nights, found out the period of this very asteroid if it has. So, period of rotation. So we may add one more data to the knowledge about asteroids. And the worlds of astronomy is part of the KITION Astronomy Academy, and we make it every year from October and June, from October till June. And this year, 2 students, Mahdessian and Matvey Dubishkin, participated in Gymnasium and Likio competitions of Cyprus Astronomy Olympiad on astronomy and astrophysics, and both became #1. So congratulations, boys. Well done. Our next Science Cafe will be dedicated to asteroids, and it is the first time when we are going to switch the date. Here it is written Tuesday, as usual, should be at the end of last Tuesday of months, but George Troullias wants to make corrections.
Mhm. Yes, because we're going to go online on the 30th of June, because we are celebrating the International Asteroid Day, and one of our 1-minute video will be presented by European Space Agency to represent Cyprus. So we're going to move the next Science Cafe instead from Tuesday 20th of June. We will move it to Thursday 30th of June, only for that month, so that we don't keep you twice online in a couple of days. So we're going to celebrate together the International Asteroid Day on the 30th of June to commemorate the Tunguska event that took place in 1908 with the big asteroid explosion. So see you all on Thursday, the 30th of June, same time, 8 o'clock, UTC +3. Thank you for being with us today. Appointment in 1 month's time. Thank you for joining.